find the total mechanical energy of a satellite which is orbiting Earth at a height small h from the surface of Earth. So over here we take Earth, mass capital M and radius is capital R, which is equal to 6400 kilometer, and at a height h from the surface a satellite of mass m is orbiting the Earth, and we have to find what is the total mechanical energy of this satellite. Obviously the total mechanical energy of this satellite is equal to potential energy plus kinetic energy of the satellite. When we say potential energy, so it is going to be minus G gravitational potential energy Gmm upon the distance between the two centers. Earth has center at O, so this is R plus H. R plus H. So this is, we can say, potential energy of the satellite, though actually this is always of interacting bodies. So it is minus Gm upon R plus H, and the kinetic energy is half m v0 square, where m is the mass of satellite and v0 is its orbital velocity. To find the orbital velocity, we use the concept of circular motion, that is, this mass is moving in this circle of radius r plus h with the velocity v0, so it requires a centripetal force which is mv square upon the radius of circle in which it is moving, that is r plus h. This is the requirement of centripetal force, and who is going to meet this requirement? That is gravitational force of attraction between the two, that is Gmm upon r plus h square, the distance between the two square. So over here we see v0 square is equal to Gm upon r plus h. So kinetic energy of this satellite comes out to be half mass of satellite into v square, that is Gm upon r plus h. So the total mechanical energy comes out to be, if I have to find what is the total mechanical energy of this satellite, is equal to potential energy plus kinetic energy. Potential energy is what? That is, we say it is minus Gmm upon r plus h, plus kinetic energy is half m Gm over r plus h. So the total mechanical energy comes out to be potential plus kinetic energy, that is minus Gm upon r plus h plus half m v square. V square we have put it from here, it comes over here, so this comes out to be Gm upon r plus h, we have taken it common, so this is minus 1 plus half comes over here, minus 1 plus half is minus half, so this comes out to be minus Gmm upon 2 r plus h. And now a very usual substitution which we have been using, that is, on the surface of Earth, if there is a body of mass m and we are taking mass of Earth as capital M and radius is capital R, then the force of attraction between this body and Earth is Gmm upon r square, where r is the radius of Earth. The distance between the two is capital R only, because the dimensions of this body, they are almost negligible as compared to the radius of Earth, which is 6400 kilometer. So Gm upon r square is going to be equal to mg. M and m, they get cancelled, so Gm comes out to be equal to gr square. We can substitute Gm is equal to gr square over here, so this comes out to be minus gr square m upon 2 r plus h. So whether we write the total mechanical energy of the satellite in this form or in this form, that is one and the same thing.